Hello everyone, my name is Joe Scorsone from Scorsone Enterprises, and in this video we are going to be talking about the Transient Impact Model. This is a tool that is very useful intraday, but I'm going to show you guys some research that I did that it can be to show how it can be used as a mean reversion strategy. This is more so about the overall research. The conclusion is still a little vague about how specifically to do it, but I think that with such a loose concept around it, something I just threw together, I think the results are pretty great. So I'm not going to code it. I already have it all set up. I'm just going to go through and talk about it. It's all coded on QuantConnect. So yeah, we're going to hop right into it. If you guys like to actively trade, check out the algorithm I made in collaboration with LuxAlgo. It's a machine learning algorithm unlike any other one you've seen. I use different techniques about how I train it and what data I give it to make sure that it is very, very hard for this model to be overfit. The link to this will be in the description. Back to the video. So now we're going to start off at this article because this is actually what the formula is from. I remember at first I kind of just I knew that transient impact models were a thing, and I got smarter. Like I understood how garbage models worked, and so I was like, let me come back to transient impact models. So I just prompted an LLM. I was like, give me an article about transient impact models and provide the source. So here we are. This is what we're going to be working with today. Well, really just this, and we're going to make it a little bit simpler. But yeah, this is overall the thing that we're going to be building it off of. This article will be linked in the description. So another thing that will be linked in the description is the research that I actually wrote on QuantConnect with it. This is where all the code will be. If you guys get 3 upvotes on this, then this will become public. I would really appreciate it. And yeah, the link to this will be in the description, but it's not like public on QuantConnect until it gets 3 upvotes. So I really appreciate that. But yeah, let's head into this code now. So we just need these imports. Minimize that just so it's a little bit prettier. And so now let's talk about how we're making this into a mean reversion strategy. So we're just going to do this on SPY, and we're starting at 2000, right? Because my goal for this is really just to predict the big downturns like 2001, 2008, 2015, 2018, 2020, 2022. That's all I really care about. And I'm doing this on daily, so I want to capture that. So we have a look back. I'm annualizing. I'm just using 252 days. And then this is just store our data. We're going to get to initial params a little bit later. So we get into our on data, and we're pretty much just storing data, right? Getting all of our data together, making sure that we use a warm-up. We're warming it up so that way we don't just have like a long line of no trades while we're getting data. And then we are going to actually get a list of volume because that's what we're really going to be gauging this. So a list of volume and our log returns. Next, what we're going to do is we're going to minimize our transient impact function. So if you guys have watched the Quant Finance Advent of Code, it's the same concept of the Garch volatility, kind of how you have this function, you have these parameters, and now you have to figure out what parameters to actually use. So we're going to minimize it. So we have this alpha, this beta, and this lambda. Alpha represents the instantaneous impact of a trade. Beta represents the magnitude of the past trades transient impacts, and lambda represents the time decay of it. Yes, I read that. That's what these things represent, and we're doing this based on volume, not based on literal bid or ask trades. And I'm doing this to keep it general, so that way we can really have a good idea of what to go off of. Because guys, remember, backtests are not marketing. Backtests are ways to validate or nullify market hypothesis. So we're going to use this to see if transient impacts models can be used to spot mean reversions. So we're going to get our volume, make sure it's a NumPy array. Now we're going to get the instantaneous impact, which is our alpha times the last volume, the last trades. So now this transient is going to be a list or a NumPy array, really. So it's going to be our beta, it's going to be our past impacts, times the sum of all the volume up to t, because we're looping. So all the volume up to t, we're looping through all of our volume. So we're going to go through kind of linearly, all the volume up to t times, and then our time decay, which is e to the negative lambda times t minus np dot range t, which is returning evenly spaced values with a given interval. So it's like time, pretty much. That's how I like to think about it. Is it's like a linear kind of array of time. That's how I think about it. Let me know if that's a weird way to. So that is the impact that we expect from the decay. So now this is our transient, this is our instantaneous. This is what we expect to go away, this is what we expect to have now. So our predicted change is those two combined. Then remember, because this is still a list. This is still a list because this, or an array really, a NumPy array. This is still a NumPy array because this is a NumPy array, this is a NumPy array, and volumes and volumes and NumPy array, right? It's in both of them, volumes and NumPy array, and we're actually explicitly saying that this is one. So our predicted change is these two lists added up, so by their indexes pretty much. And then what we're actually getting is the sum of our log returns minus the predicted change squared. That is actually what our transient impact is. So on any given bar, if we have, given we have enough volume for this to be accurate, right? Which is a weird thing to say now that I think about it, because I'm also going to drop this for you guys. The stock market is not normally distributed, so the law of large numbers does not apply. Our prediction may not be more accurate just because we have more data points in volume. Think about that. So we have here our log returns minus predicted change squared is our transient impact. So on the most recent bar that we have, that is what on the most recent bar that we have from our time series, right, as we get data in on the most recent one, this is what we expect our transient impact value to be. So we're going to get that here. Actually, no, excuse me. That is what we're going to get here, but first we have to use minimize. Minimize is what we used in the QuantConnect identical code to define the Garch model volatility. So it's just from SciPy. It makes things really, really, really simple. You could just do gradient descent. You could just do something like that to get down to a small value, but we're going to use the imports, right? Because we're using Python. Why would we not use SciPy? Why would we not use NumPy, right? Practicality. There's something great in knowing how things work. There's something great in saying, okay, let me make sure I remember what this method really is, CG. Okay, I thought it's on their website, what CG actually is. But, oh, it's about CG. It uses a nonlinear conjugate gradient algorithm by Pollack and Ribéry. I definitely pronounced that wrong. A variant of the Fletcher-Reeves method. So I did choose this on purpose because nonlinear and gradients. I knew the word gradient. I knew the stock market was not normally distributed, so nonlinear makes sense. So that's why I chose CG. Does it affect the output a lot? No. Is it a great detail? Yes. So we're going to use this minimize function with this method to get to the minimized values, the minimized parameters. Remember, we have these initial params. We're starting at just that, but we want to get the most accurate value. So we're going to use log returns and volume as our other arguments, because remember, we need those. And then our params are initial parameters, and we're minimizing this function. So the results is like this. Alpha, beta, and lambda is results.x. So when we actually want to get our transient impact with these optimized parameters, I'm logging it so that way it's just a little bit prettier, but doesn't really matter. It's still like the same number. I'm just logging it so it's a little bit easier on the eyes, log base 10. But we're going to get the transient impact with results.x with these parameters, volume, log returns, and I'm adding the small value just in case I would ever have a scenario would be a log 0. Don't want that to happen. So just adding a super small value to it. Now, to make this into a strategy, I'm doing something ridiculously simple. What I'm doing is I'm just adding it to a rolling window of length 3. Why? Because you need 3 points to have a we need 2 points. What's the saying? Oh, I would always think about this saying, but it jumped out of my head. You need 2 points for a line and 3 points to confirm a line. Something along those lines. So that's why I chose 3, and I also chose 3 because once we add it to the window, or I'll also plot it, make sure the window is ready, and then we can see if we had a little local minima in there. We want to buy on a low transient impact. I'll get to that later. But to make this more sophisticated, we could use a longer window and check if the most recent index is a saddle point or not. That's actually what you would want to do. A little bit of Calc 3. I didn't really want to dive into this until I had a good reason to make a lot of content about it, honestly, because I also don't have a reason to use it in my personal one. So if you guys like this video, I'll make a second part to it. If you guys like this video, I mean, like if one person comments, I really enjoyed this, I'll make the second video. You don't have to hit a like goal or something like that. I'd appreciate a subscribe and a like, but you don't have to. Regardless, we're going to check if we're at a minimum. So we just want to make sure that our last index, oh gosh, this always messes with me. We're going to say our last index is greater than our middle index, and our most recent index is greater than our middle index. So we kind of get this little dip right there. We want to get in on that confirmed little dip. So that's what we're seeing right here. This would either be true or false. So make sure that we have a little dip. Make sure that this parameter is the little dip, is the little, right? I'm just gonna, when in doubt, if you guys watch my channel for a while, you know what I'm going for. When in doubt, Microsoft Paint. So I just want to make sure that we're there, right? Because, so this would be 2, 1, and zilch. I want to enter here. That's what I want. Also, I found out about this. Oh wait, do I have to hold space or something? Yeah. If you hold space, shift, and an arrow key, you could draw on it like an etch-a-sketch. I learned that because I came across one of Pirate Software's videos, one of his YouTube shorts. This blew my mind. MS Paint's the best program ever. But yeah, that's what we're looking for. We're looking for those little minimums, and a better way to do that could be to use. Could it even technically be derivatives? Well, saddle points uses partial derivatives. I'm not too certain. I'd have to actually sit down and think about it. But I know that saddle points would be a thing. I just took Calc 3, not Calc 1, right? That's what's fresh. But so yeah, if we have a minimum and we had a little bounce, then we're going to long off of recent dips. And if we had a little minimum, we had a top, then we're going to long off of, or short off of recent tops. So that's kind of like mean reversion, I think, has a bit of a odd rap, because if this is our price right here, mean reversion strategy, you would look for it to short right there, right? But mean reversion could also be buying right here. Oh my gosh, that was a bad arrow. Buying right there. Why? Because let's say we have, I'm gonna make this so dramatic just to get my point across. So let's say we have this equity right here, right? This is our price. We actually went back in time a little bit, right? Let's say that there's actually something that looks like that. And so just for the sake of simplicity, our mean would be something like that. Something like that. So for this to revert to the mean, you would have to short it. For this to revert to the mean, you would have to long it. Does that make sense? This is what I'm trying to get at, is that these are both of these price deliveries at some point is a mean reversion. Does nothing look like that? Probably, right? I mean, nothing goes back in time like this. Nothing goes left. That always goes right. But that is the point that I'm trying to get across, is that mean reversion can include longs and shorts. So that is what we are doing right here, but we're making sure that we have the transient impact on our side as well. So now to actually enter these trades, we're checking for one of these scenarios, and we're using set holdings, so that way I don't have to worry about order management. If you just set true with set holdings, param liquidate existing holdings is a boolean. If you set it to be true, it liquidates everything that you're holding before it enters the new position. So if you were to run this just as is, you would end up with this backtest, which profits off of the 2000 bubble, 2001 bubble, profits off of the 2008 bubble, profits off of the 2015 currency crisis. Well, actually, we skipped one. Didn't do too great in 2018. Didn't do too great in COVID, and had a great 2022. So actually, I don't even remember what the win rate is. Win rate's only 42%, which is kind of crazy. But right, that is what I was kind of looking for right there. I didn't really care what happened in the meantime, because the buy and sell logic is only contingent on transient impact. But this is what I was looking for. I was looking to see these. Can I get the benchmark? I sure can. and I'm gonna just get rid of these for now. This is what I was looking for, was we get our top as, or we're going down actually as the model's breaching. It didn't quite grab the bottom, but that's still okay. And here our peak is pretty much right before the bottom in 2009. Here in 2015, our peak matches up with this bottom, and we got another bounce, another little bit of a bounce right after it, which is exactly what I was looking for. 2018 did not work out very great at all, right? And 2020, it was fine. And then 2022, we did have some nice appreciation, and it actually kept going into that. So now let's count this up. 1, 2, 3, 4, 5, 6. Out of those 6, we have 1, 2, 3, 4 that worked out. So now this is not how to actually conduct research, but what this is telling me, what this backtest is telling me, is that more often than not, over 50% of the time, the transient impact model could spot a mean reversion. We could use the transient impact model to correctly get into a mean reversion. So now I actually didn't go into this. So now why do we want to enter on these dips? We're going to get into pain again. Why do we want to enter on those transient impact model dips, right there? Even if the stock's going up or down, we'll worry about that later. Why do we want to worry about that dip? Well, because when a big firm, think like you're a big bank, think you're a Goldman Sachs for a second, and you have to take a trade that's worth your while. You need a lot of size. You need a lot of your position. Your position is going to be huge. You need a lot of size. So if your stock is doing whatever it's doing, and all of a sudden Goldman Sachs comes in and takes a long with their full position, it'll go nuts, right? Or the opposite, if Goldman Sachs liquidates their full position at once, right, would not be good. Nobody wants to manipulate the market. Nobody wants to obviously manipulate the markets like that. And also that's not good for trading because they want their trade to work out. So what they'll do is they'll have this is the equity, right? We'll call it the equity. We'll say that this is on a daily time frame, just because why not? This is the same concept, daily, minutely, whatever. And then I'm going to use the green for, no, I don't want to use that in case I want to mark buy and sells. Use the blue for the transient impact. Let's say that I'm going to sync these up so that way I can show you guys when I would want, like what good trade entries could be by using the transient impact. So on this dip right here for transient impact, that is ideal case scenario for new money to come in because we had a low impact. Trades aren't impacting price so much right now. That is where you want to get in. This is not where you want to get in. This isn't even where you want to short. It's where a bunch of other stuff has already happened, right? Because we have this downtrend right here. This peak pretty much means that these orders had a big impact on what just happened. So now we can keep on going through. The little peak, a little bottom right there. That's where I want in on that bottom. Even right here, we're at the top, but we got a little dip in our transient impact. We got a bit of a low impact right now. Could be a short, right? Because we had a little bit of a dip relative to before. Yes, it's not as low. Partially me drawing, partially just because it's not as low, right? We also have a dip right here. It could be a long. The little dips right here. It could be small trades. That is how we want to trade off the transient impact model. We want to get in when the impact is low because that is when other people with lots and lots of money are also going to be trading. So that's what we're trying to spot with this is when pretty much when is the big money going to come in and just mollywop that thing back down or ride that wave of the crash and try to make money off of it, right? Because everybody's allowed to short. You know, you're allowed to short things. So yeah, but that's the video. That's all the information that I have for you guys about the transient impact model. Like I said before, if you guys get this community research post up to 3 upvotes, and you guys can have the code. If you guys have a QuantConnect account, you can just go and upvote it. It doesn't cost anything to upvote it, but yeah, all the code would be right there. Other references too, and all the codes are here. Yeah, I kind of just want to be on this page for research. Kind of just want to be here. I don't have anything. I don't even know who these people are. It's not a grudge. I just want to have the accomplishment. Um, so yeah, I think that it would be. I think it would be really cool. I'd feel pretty damn good about it. And there's also other articles that I have linked in the description. Like, there's so much. There's so much information here. I'm sure that all you smart and awesome people that watch my videos, I'm sure that you guys would have a lot of. This was written very recently. I didn't even catch that. I always just assume these things are from like the 1600s. That's pretty cool. I don't even know if we traded in the 1600s. But yeah. Oh, Italian. They're all Italian. This is from Bologna. Oh, is it a surprise? One of it's from the two of them are from Italy. One of them is from London. That's so funny. All right, I'm gonna stop before I crash out even harder. So there's the article. I'm gonna put more articles in the description. This code will be available contingent on all those upvotes on that research post. I already spoke about my indicator with LuxAlgo. I do have a second one as well. I'm not gonna edit this. I'm just gonna pull it up because if you guys remember, Prometheus Analytics, that is now no more. All of us just kind of went to do our own thing, but I'm still a dev. So if you guys want the free reversal script, it's free. You guys could just get it on TradingView. I'm going to link my TradingView account. You guys can get access to all this stuff. Some of it's still called Prometheus. I'm keeping it that way. You know, a little homage. But yeah, I hope that you guys enjoyed this video. And also, there's really nothing stopping you from just like pausing and actually writing the code out right there. I just want the upvotes. If you do that, I don't care. I just want the upvotes. But yeah, I'm gonna stop yapping now. You guys all have a great time. The next videos, I'm either gonna do a second. The next video is probably not gonna be this, just to switch it up, keep something fresh. If you guys know the content creator Anthony GG, very smart guy. He made a video about TCP models and Golang, TCP servers in Golang, and I made a TCP model. I made the TCP server, and I made it connect to channels, and I allowed users to connect to those channels. So that way, you could actually have a text conversation back and forth between two users. So I kind of want. I just did it to do it. I don't really care about that stuff, but it's kind of cool to have your own protocol in there, like join whatever channel and then message and then the channel name and then making sure that you're actually in the channel and stuff like that. Actually uses a lot of concurrency and stuff like that, a lot of cool things to make it run the way it should. So if you guys want a video about that, that's what I'll do next. And well, that's what I'm going to do next regardless. And then I'll probably come back to the transient impact model or something else that somebody asks for comes across my radar. But yeah, hope that you guys enjoyed this video. My name is Joe Squareson, and I will see you guys in the next one. Goodbye.